Okay, so on the chapter 6 quiz, there will be a section on the short answer where you have to circle either increases, decreases, or remains the same based off the sentence. So it is all related to confidence intervals and how the width changes as you change your sample size, margin of error, or the confidence level itself. So as sample n increases, the confidence interval width decreases. So the reason for this is that n affects your standard error. So your square root of p hat times 1 minus p hat over n. So as you increase n, you decrease your standard error, which then decreases the width of the confidence interval. As the margin of error increases and we maintain the same level of confidence, the standard deviation must increase. So remember, margin of error is your critical value times the standard error. So if we are increasing our margin of error, but we're keeping the same level of confidence, that means our critical value isn't changing. And obviously p hat isn't changing. So that means that all of the standard error has to increase in order to increase the margin of error. As confidence increases, the sample size must what in order to maintain the same margin of error? And that's going to be increase. So something to remember is as you increase confidence, you actually decrease the width of the confidence interval itself. So that means your critical value gets bigger. So your critical value increases as your confidence increases. So because margin of error is the critical value and the standard error, if you want to maintain the same margin of error, the only way for that to happen is if n also increases, because then your standard error decreases. If the margin of error increases, the confidence interval width increases. So that one's pretty straightforward. Margin of error determines the width of your confidence interval because it's always p hat plus or minus the margin of error. So if your margin of error increases, so does the width. As confidence increases, the standard deviation must what in order to maintain the same margin of error? So this is going to be decrease for a very similar reason as C. So the difference there is if you increase sample size, you decrease your margin, your standard error. So it ties in directly to C. And then as our confidence level increases, the margin of error will increase. Because again, critical value, if you increase confidence, you increase the critical value, which increases the margin of error. All right, so the rest of the short answer questions are going to be a combination of either doing a single proportion confidence interval or significance test, or a difference in proportions confidence interval or significance test. It's not going to be one of each, because that would make the quiz really long. It's only one confidence interval and one significance test. So in a random sample of 250 high school students, it was found that 230 of them later graduated. Find and interpret the 98% confidence interval for the true proportion of all high school students who graduate. So the first thing we want to find is our p hat and our critical value. So p hat is your total number of successes, 230, over your sample size, 250. And that's going to give us 0.92. To get our critical value, we have to do INV norm. So this is not something I give you on your formula sheet. You do have to know how to do it. You don't have to show me the work on the quiz, but I am showing you how I get my critical value. So for the area, it has to be the remaining area to 100% divided by 2. So if I'm at 98%, that leaves me with 2%, which divided by 2 is 1%, and 1% as a decimal is 0.01. You never change the mean and standard deviation. They stay 0 and 1. It does not matter which side you make the tail. It can be left or right. We ignore the negative when we do it, so that's going to give us 2.33. We ignore the negative for now because that's what the plus or minus in the actual formula is. So when I go to plug everything into my formula, we have 0.92 plus or minus 2.33 times the square root of 0.92 times 1 minus 0.92 all over n, which is 250. When it comes to what do I expect you to do on the quiz for work, I do expect, if you don't have a specific p-hat to start with, for you to calculate it, you do need to tell me the critical value. You do need to set up the confidence interval using the formula. You can go directly to the confidence interval itself after this, or you can do the part where you tell me what you're adding and subtracting. So when I do 2.33 times the square root of 0.92, 1 minus 0.92 all over 250, I get 0.03998. So to 2 decimals, it's going to be 0.04. Because even if I tried to go 4 decimals, those 2 nines make it round up. So then I do 0.92 minus 0.04, which is 0.88, and then 0.92 plus 0.04, which is 0.96. And then my last step is my sentence. So all sentences start with we are, and then whatever percent confident you are. So 98% confident. And then that the true proportion. In this case, it's your problem, what you're trying to solve for. So of all high school students who graduate, is between, and then you can convert it to a percentage or you can leave it as a decimal. So 0.88 and 0.96. So you have to have the critical value, you have to have the formula, you have to have the confidence interval, and then you have to have the sentence. The p-hat is really just dependent upon whether or not you're given a p-hat to start with or if you have to calculate it. So sometimes not. In our next example, we have that a U.S. Coast Guard survey of 300 small boats in the Cape Cod area found 120 in violation of one or more safety regulations. Given 90% confidence estimate for P, the true proportion of all unsafe small boats. So I'm going to start with my p-hat, which is going to be 120 over 300, which is 0.4. Then to find my critical value, we do I and B norm. And then my area is, so the remaining percent to 100 is 10. 10 divided by 2 is 5. 5% as a decimal is 0.05. Mean 0, standard deviation 1. And this is the weird one where we typically go 3 decimal places. So you can use 1.645. You don't have to. You can also just use 1.64. I will have both as acceptable answers for something like this on the quiz. I'll have both confidence intervals as correct answers, but this is the 1% where they typically go 3 decimals instead of 2. So when I set up my interval, 0.4 plus or minus 1.645, and then the square root of 0.4 times 1 is minus 0.4 all over 300. So when I do 1.645 times the square root of 0.4 times 1 minus 0.4 all over 300, we're going to get 0.4 plus or minus 0.0465. so I now subtract that from 0.4 and we'll get 0.3535. And then when we add it, we get 0.4465. And for our sentence, we are 90% confident that the true proportion of all unsafe votes is between 0.3535 and 0.4465. In our next example, we have that a pollster is hired to determine the percentage of voters favoring the Republican presidential nominee. If we require 99% confidence that the estimated value is within 2% of the true value, how large should the sample be? So the formula to solve for a necessary sample size is on your formula sheet. So you don't need to memorize it. So there is 3 things you need, though, to plug into the formula. The first is your margin of error. So for our problem, the margin of error, they say that we want to be within 2% of the true value. So that's our margin of error, which is, as a decimal, 0.02. To find our critical value, that's based off our percent confidence, so 99% confidence. So you do INV norm with an area of 0.005, and you get 2.58. And then the last thing you need is a p-hat. Now this is this is not something I'm going to give you on the formula sheet. So there's a rule for this, that if you aren't given a previous p-hat, you have to use 0.5. So they don't give us a previous p-hat. So my p-hat is going to be 0.5. So that is something you do need to know. So when I plug it into the formula, I do the critical value, 2.58, divided by the margin of error, 0.02, and then squared, times p-hat, which is 0.5, and then 1 minus p-hat. Okay. Literally just plug that into a calculator. You get 4160.25. And then you do have to round up n no matter what the decimal is, because it's always a minimum sample size. Because if I round down, I don't actually meet the margin of error. So you always have to round up. So it's going to be 4161, and then you do want to put units, which in this case would be voters. Anytime it's people, I also accept people. You can be specific though and say voters. Our next example says the school superintendent wants to know what percentage of property owners are willing to support an increase in school taxes. What size sample should be obtained to determine with 90% confidence the support level to within 5%. So it's exactly the same as the previous problem. So margin of error is the within 5%. So that's going to be 0.05. My critical value comes from my level of confidence, which is 90%, which we calculated in an above problem. So it's 1.645. Then again, I'm not given a previous p-hat, so we're going to use 0.5. So n equals 1.645 over 0.05 squared. And then times 0.5 times 1 minus 0.5, which is 270.6, which rounds up to 271 property owners. Alrighty, So let's do a significance test. So it says, suppose that early in an election campaign, a telephone poll of 800 registered voters shows that 460 favor a particular candidate. Just before Election Day, a second poll shows that 520 of 1,000 registered voters now favor that candidate. At the 2% significance level, is there sufficient evidence that the candidate's popularity has decreased? So whenever you have a difference in proportions, the first thing you have to do is define your P1 and P2. So I'm going to let P1 be the early poll and P2 be the late poll. It does not matter which one you pick to be P1 and P2. It will affect how you write your alternative hypothesis though, which is why we have to define them. So the null hypothesis is always P1 equals P2, always. The alternative hypothesis is then based on the wording of the problem. So it wants to know if the candidate's popularity has decreased. So that would mean that their popularity in the early poll should be greater than their popularity in the late poll. So we're testing to see if P1 is greater than P2. Okay. There are three things then we need to calculate to do our test statistic. We need P1 hat, we need P2 hat, and then we need the pooled proportion PC hat. So P1 hat is going to be 460 over 800, which is 0.575. P2 hat is 520 over 1,000, which is 0.52. And the pooled proportion, not something you have to memorize. It is a formula on the formula sheet. It's your number of successes from each population over the sample sizes added together. So our numerator is going to be 460 plus 520, and then our denominator is 800 plus 1,000, which becomes 980 over 1,800, which is 0.544. 3/4. Right. Now I want to calculate my test statistic. So again, not a formula you have to memorize. It is given to you on the formula sheet. So what we're going to do now is Z equals, and then it's always P1 hat minus P2 hat, so 0.575 minus 0.52, and then the denominator uses the pooled proportion. So 0.5444 times 1 minus 0.5444 over the its sample size, 800, and then we do the same thing for the second sample size. So 0.5444 times 1 minus 0.5444 all over 1,000. The hardest part about a difference in proportions is plugging this formula into your calculator because you don't want to mess up your denominator. So if you don't know how to do the fraction button in your calculator, and you can't ever get your parentheses correct, please let me know and I will help you with putting this into a calculator so your parentheses are correct. So then we get Z equals 2.33. You can do 3 decimal places if you want for Z. I only require 2. The only time I require 4 decimal places is if it is strictly a decimal. Like if it is smaller, if it is between 0 and 1, or when you get to the Z-score, it's less than 1. That's the only time I really require 4 decimal places. So now we're going to go to normal CDF. Our lower bound is our test statistic, 2.33. The upper bound is the 1E99, mean of 0, standard deviation of 1. And we are going to get 0.0099. Okay. Now we compare this to our alpha, which is 0.02. And it is less than, so I'm going to reject my null hypothesis. So you do have to specifically say reject or fail to reject. And then our sentence, there is enough evidence to show that the candidate's popularity has decreased. So one question I get a lot is, how do I know the difference between a confidence interval and a significance test? So it is specifically going to say the words confidence interval when you need to do a confidence interval, and it's going to mention a significance level or a significance test for a significance test. So, I mean, the words in the problem do indicate which one you are going to be doing. So the last short answer question says, give a 99% confidence interval for the difference in the percentage favoring that candidate in the two polls. Is your conclusion consistent with your conclusion to number 6? Explain. So I just need to calculate my critical value. I'm not going to recalculate my p-hats because I just did that. So when I do a 99% confidence interval, I do INV norm, and my area is 0.005. And we've already done this, so it's 2.58. So we're going to do 0.575 minus 0.52 plus or minus 2.58. And then the square root. Now, for a confidence interval, we use our P1 hat and our P2 hat. So 0.575 times 1 minus 0.575. Over 800, and then plus 0.52 times 1 minus 0.52 all over 1,000. So then in the calculator, when I do 0.575 minus 0.52, we get 0.055 plus or minus, and then it becomes 0.0608. So it is okay to get numbers in your confidence interval that are negative. It just means that means there's a chance that the second proportion actually ends up being bigger than the first one is a chance. So 0.055 minus 0.0608 gives us negative 0.0058. And then 0.055 plus our decimal is going to give us 0.1158. So if I were to want this to be consistent with my hypothesis, if I want to reject, then my confidence interval shouldn't contain the number, couldn't contain 0. Because in my significance test, I'm saying P1 is always greater than P2. So my confidence interval should back that up. So that means they would all have to be positive in this case. And because my confidence interval does contain negatives, the answer is no, because the confidence interval contains 0. So So if all of my numbers were positive, it would back up my conclusion because then P1 is always greater than P2. But there is a chance that it's not, so it doesn't back it up. So for the multiple choice practice, our first problem says a national tabloid newspaper wants to estimate the true proportion of all people who believe that life exists elsewhere in the universe. What is the least number of people that should be sampled in order to estimate the true proportion of those who believe that life exists elsewhere within 4% of the real answer with 95% confidence? Past data indicate that 30% of the general population holds this belief. So unlike the previous two examples we did where you have to solve for your sample size n, we didn't have a previous p-hat, but now we do. So when I plug it into my formula, our critical value for 95% confidence is 1.96. 4% margin of error becomes 0.04 squared, and then we'll have times 0.30 times 1 minus 0.30. And we're going to get 504.21, which you have to round up to 505. The next question says, an airline would like to add an early morning flight to one of its popular business routes if there is sufficient demand. In order to get an estimate of the number of business travelers who might use this new flight, it takes a random sample of business people who have taken one of the current existing flights. If the airline constructs a 98% confidence interval to estimate the proportion of business travelers who would take the new flight instead of a 95% confidence interval, which of the following statements is true? So the biggest thing to remember about changing confidence level, if you increase the confidence level, you increase the confidence width. All right, that's probably one of the biggest things you need to remember. So I'm looking for the ones that say that the 98% confidence interval would be wider, which means I can get rid of C, I can get rid of D, and I can get rid of E. So now the question just becomes, is the 98% confidence interval more or less precise? And the wider the interval, the more precise it is. So the answer is going to be B. Next one says, which of the following are true statements? Tests of significance are designed to measure the strength of evidence against the null hypothesis. A well-planned test of significance should result in a statement either that the null hypothesis is true or that it is false. If there is interest in deviations in only one direction, the null hypothesis is one-sided and expressed using less than or greater than. Okay. So, the first statement. So that is true. We are always trying to gather evidence against the null hypothesis because our goal is to always reject the null hypothesis. The second statement is false. We are never actually saying that the null hypothesis is true or that it is false. We're either rejecting it or we're failing to reject it. There is a typo in statement 3. This should say alternative hypothesis. And this is a true statement. So if you're only interested in one direction, then it's a one-sided hypothesis test, and you either use less than or greater than. So then the one that is correct is B. The school superintendent wants to know what percentage of property owners are willing to support an increase in school taxes. What size sample should be obtained to determine with 90% confidence the support to within 5%? So again, solving for n. So with 90% confidence, our critical value is 1.645, margin of error 0.05. squared, and then not given a previous p-hat, so we use 0.5. And we're gonna get 270.6, which we have to round up. So it's gonna be 271. Using the same data, one student performs a test where the null hypothesis is p equals 0.85, with the alternative hypothesis p does not equal 0.5. A second student performs the test with the same null hypothesis, but this time the alternative is that p is less than 0.85. Both students use a 5% level of significance. The first student claims there's not enough evidence to reject the null hypothesis. The second student says there is enough evidence to reject which of the following could have been a value for the test statistic. So here's one thing that we want to pay attention to is the alternative hypothesis. So it does not equal and less than 0.85. So when we're trying to figure out our test statistic, we're going to go based off the second student because they specified a direction. So because they specified a direction being less than, our test statistic is negative. All right, and that is specifically because if you're less than, it needs to be negative. So you can get rid of D and E. The only other way to really determine which one could have been is then start doing normal CDF. So you're going to do normal CDF for each of the three and figure out, so student one, because they failed to reject, and that means we're looking for a p-value greater than alpha. And then student 2 is rejecting we're looking for a p-value less than alpha. So it's just plugging in negative 2.3 in, and then negative 1.8 and negative 1.3, and figuring out which one gives you the answers. The important thing is when you do it for student 1, you do have to double the p-value because the alternative hypothesis does not equal. So remember, double p-value. So when you do this, you end up with B being the correct answer. So if you have a test statistic of negative 1.8, you get failed to reject when it's a does not equal alternative hypothesis, and you reject when it's a less than. Okay. Number 13, which of the following statements are true? If a population parameter is known, there is no reason to run a hypothesis test on that population parameter. That is false. You can still run a hypothesis test. The p-value can be negative or positive depending on whether the sample statistic is less than or greater than the claimed value of the population parameter in the null hypothesis. That is false. Your p-value, you got to remember, is a probability. Probability can never be negative. Your test statistic can be positive or negative, but the p-value always positive. And then the p-value is based on a specific test statistic, so it must be chosen before an experiment is conducted. And that is also false. So remember, you can't choose your test statistic before an experiment is conducted. You have to wait until after you have determined your hypotheses, and then you get your sample. So none of these are true. Next one says, a national tabloid newspaper reported that 30% of adults in the general population believe that life exists elsewhere in the universe. A TV news station surveyed a random sample of adults from the general population and reported that 36 out of 100 sampled hold this belief. A right tail hypothesis is performed. What is the conclusion at a level of significance of 10, 5, and 1%? So the right tail hypothesis means that the alternative hypothesis is greater than. So that's what we mean when we say right tail. P is going to be greater than 0.30. So now we need to find our test statistic so we can calculate our p-value. It doesn't matter though in this case. All of the p-values for the multiple choice questions are 0.0952. So calculating it doesn't actually matter. If one of these had been different, I would have calculated my test statistic so I could figure out my p-value, the correct one. But they all have the same p-value, so I don't need to do that step. So now I have to just determine at what levels we're rejecting. So 0.0952 is less than 0.10. So we are going to reject. So it is significant. But 0.0952 is greater than 0.05 and it is greater than 0.01, which means we failed to reject at these levels. And it is not significant. So I'm looking for the multiple choice answer that says that. So it's not A, because it's not reject at all three. So this one says rejected at 10% and 5%, which is also not true. C says dispute at 10%, so that means reject, but not at 5 and 1%, which does go with what we claim. I'm still going to double check the last two just to make sure that they're wrong. So this one says reject at 1, but not 10 and 5. And then that one says there's not enough evidence. So that one's also not true. So it leaves us with C. Next, we have a poll was conducted to determine the level of support within a large suburban school district for the construction of a new football stadium. Of the 655 people surveyed, 57% said they would support spending the money to construct the stadium. The poll had a margin of error of 4%. Based upon this 95% confidence interval, what level of significance should be used to test the null hypothesis P equals 0.5 versus, and this should say P does not equal 0.5. So remember in the notes, it did say that a two-sided hypothesis test and a significance level, if you have the alpha and the confidence level should add to 100% and they should support each other. So if we're doing a 95% confidence interval, the level of significance should be what gets you to 100%, which is B, 0.05. All right, and then the last two questions use this scenario. An agricultural researcher wishes to see if a kelp extract helps prevent frost damage on tomato plants. Two similar small plots are planted with the same variety of tomatoes. Plants in both plots are treated identically, except that the plants on plot 1 are sprayed weekly with a kelp extract, while the plants on plot 2 are not. After the first frost in the autumn, the percentage of damaged fruit is determined. For plants in plot 1, 20 of the 100 tomatoes on the vine exhibited damage. For plants in plot 2, 36 of the 100 tomatoes on the vine showed damage. Let P1 be the actual proportion of all tomatoes of this variety that would experience crop damage under the kelp treatment, and let P2 be the actual proportion of all tomatoes of this variety that would experience crop damage under the no kelp treatment, assuming that the tomatoes are grown under conditions similar to those in the experiment. All right. So, in the first question, we want to set up our confidence interval for a difference in proportions. So P1 is 0.20, P2 is 0.36. So that's the first thing I'm going to do is the subtraction. And that leaves me to negative 0.16. So that means I can get rid of D and E. Now I need to find my critical value and do my standard deviation. So for a 99% confidence interval, the critical value is 2.58. And then we do the square root of 0.20 times 1 minus 0.20 over 100, and then 0.36 times 1 minus 0.36 over 100. And we get 0.1612. So I'm looking for the one that is closest, which is C. Okay. So using the same information, we want to know, is there evidence of a decrease in the proportion of tomatoes suffering frost damage for tomatoes sprayed with kelp extract? To determine this, you test the hypotheses, P1 equals P2, and the alternative P1 is less than P2. So we want the p-value. We want to know where the p-value falls. So first I need to find my test statistic, which means I need my pooled proportion. So we're going to do 20 plus 36 over 100 plus 100, which is 56 over 200, which is 0.28. So I do my test statistic. My numerator is going to be negative 0.16 because I already did that before, 0.20 minus 0.36. And then in the denominator, 0.28 times 1 minus 0.28 all over 100. And then I have to do it twice because I have to do it for both sample sizes, even if they have the same sample size. On the quiz, if you have something like this, that's a multiple choice question, I don't expect you to show me your work because it's multiple choice. So it's not like you get partial credit for showing your work. I'm showing my work so you understand how I arrived at my answers. So test statistic of negative 2.52, and then we do normal CDF. So the lower bound is negative 1 E99. The upper bound is negative 2.52. Mean of 0, standard deviation of 1. And we get 0.0059 as our p-value. So now I just have to figure out where it falls. So it's 0.00, so it's not going to be larger than 0.10 between any of those. It's not smaller than 0.001, so the answer ends up being D. Okay. Please let me know if you have any questions about confidence intervals or significance tests for single proportions or difference in proportions, especially if it's figuring out which formula you're using from the formula sheet, how to find the critical value, how to find your p-value. Just please let me know.